AB Calculus, Section 5.4, page 2. Continuing to evaluate some definite integrals. When we look at this first one, it might be helpful for you to rewrite that as 1 over 1 plus x squared dx. And now we look at this and we think what thing, when you take the derivative of it, gives us 1 over 1 plus x squared? And that is inverse tangent of x. We're going to evaluate that from negative 1 to 1. So this will be the inverse tangent of 1 minus inverse tangent of negative 1. And you remember your pre-calculus, inverse tangent of 1 is asking you where on the unit circle is tangent equal to 1. There are two places, pi over 4 and 5 pi over 4. However, do you recall inverse tangent has its range in the first and fourth quadrants? So we must give an answer of pi over 4 minus, and then inverse tangent of negative 1. Tangent is equal to negative 1 at 7 pi over 4 and at 3 pi over 4. But again, inverse tangent must give an answer in the first or fourth. And when in the fourth quadrant, inverse tangent must be expressed as a negative radian value. So that is negative pi over 4. Pi over 4 plus pi over 4 is then pi over 2. And that's it right there. All right. Look at this next one. Again, I would strongly suggest you rewrite this. Going to separate out this dx from the fraction. At the same time, pull this constant multiple of a 3 out front. So we'll have 3 times the integral from 0 to 3 of 1 over x plus 1 dx. Over here, we did not have a linear piece in the denominator, so that sent us to the inverse tangent. When you have a linear piece down here in the denominator, then you think what thing gives you a derivative of 1 over, and that's an ln. So this 3 comes down, and this will be then the natural log of x plus 1, evaluated from 0 to 3. And when we plug in, then we get 3 ln 4 minus 3 ln 1. And again, you remember your pre-calculus and know that the natural log of 1 is 0. So we are left with just 3 ln 4. I do want to caution you in terms of multiple choice problems. There's a variation or an equivalent answer that we might see on a multiple choice test. So we could rewrite this 3 ln 4 is 3 ln 2 squared. And then this 2 can leap down in front and multiply by that 3. So we have 3 times 2 ln 2, which is 6 ln 2. There's that final answer. Again, that's important for multiple choice. A free response, this answer would be perfectly acceptable. However, you need to be able to manipulate with your log rules to find equivalent answers. All right, look at this next one down here. I would like you to find the area between y equals 3x squared minus 3 and the x-axis for x between negative 2 and 2. So the first thing that we'll need to do is to sketch a graph. I did do a different scale in the numerator and denominator. This is going to be a pretty steep graph, and I wanted to make sure that we had plenty of space to graph this in its entirety. All right, to graph this function, let's remember some pre-calc. Oh my, a lot of pre-calc coming back. Let's factor a 3. and then that will factor into x plus 1 times an x minus 1. So we know right there that this graph has zeros at -1 and at 1. Halfway in between, when x is 0, will be the vertex, and we see when we plug in x is 0 that -3. We know we have a parabola opening upward. Let's just plug in a -2. -2 squared is 4 times 3, 12, minus 3 is 9. So we'll have a -2, 9. Plugging in a +2 will give us the same thing. And sketching in this graph, we have something like this. And we want the area between that curve and the x-axis for x between -2 and 2. That area is this. And this piece down here between the curve and the x-axis. And we have that. I had some white out here and it's not coloring very well, but you get the idea. All right, now if we were to do the integral from -2 to 2 of 3x squared minus 3 dx, this would be the value of the integral. And it allows for negative area. We want the total positive area. So everything has to be positive. All right, now we could, and we talked about this last week, we could do the integral from -2 to 2 of the absolute value of 3x squared minus 3 dx. Absolutely, that will give us the area, but you would have to do this on a calculator. And we're doing this by hand. And we can't anti-differentiate an absolute value. Anti-ATE and absolute value. Okay, so then to find this area, we are going to have to separate this into pieces. We'll find this piece between -2 and 1, this piece between -1 and 1, turn it positive, and then find the area between 1 and 2. So let's look first to find this area between -2 and -1. That will be the integral from -2 to -1 of this 3x squared minus 3 dx. Then we'll have to subtract off this bottom piece, because when we subtract a negative number, that will turn it positive. So -1 to 1 of 3x squared minus 3 dx. Then we'll have to add in this last piece, the integral from 1 to 2 of 3x squared minus 3 dx. Whew. All right, here we go. So let's anti-differentiate. The antiderivative of a 3x squared is x cubed minus a 3x. We're going to evaluate that from -2 to 1. I'm going to go ahead and work all this one all the way down, and then we'll go do the next one. Plug in a 1, that's 1 cubed minus 3 times 1 minus, then let's plug in a -2. -2 cubed minus 3 times a -2. That's 1 minus 3 minus, and here we have a -8 plus a 6, -4 minus a -2. Uh-oh. Oops, 3 times -1. I knew I wasn't supposed to get a -4 here. I'm sorry. This should be plus 3. So that's a plus 4. And we have 4 minus... Uh-oh, let's try again. Oh, shoot. -1, -1, -1 cubed, negative. I'm so sorry. -1 plus 3, that's 2. Now we have 2 minus a -2, 4. I knew what answer I was supposed to come up with, and it wasn't working, so I had to find my mistake. All right, looking at this next one here, minus. Now, it's the same antiderivative. So we have x cubed minus a 3x, and we are going to evaluate that from -1 to 1. All right, so minus. Now I'm going to put square brackets around this so I can kind of keep everything separated, even though I am using different colors. This is 1 cubed minus 3 times 1 minus. Then we have to put in a -1. A -1 cubed minus 3 times a -1. All right, so we have 1 minus 3 minus, and then here we have -1 plus a 3. Oops, didn't need that one. And we have 1 minus 3 is -2 minus a 2, and that's minus a -4, makes this plus 4. So we still have this 4 over here. 4 plus 4. Last one, oh my, plus over here. Antiderivative, x cubed minus 3x. Evaluate from 1 to 2. So we'll have 2 cubed minus 3 times 2 minus, and we'll put in a 1. 1 cubed minus a 3 times a 1. 8 minus 6 minus quantity 1 minus 3. We have 2 minus a -2 plus a 4 plus a 4. So here we have at the end 4 plus 4 plus 4, 12. Whew. Lots of arithmetic in there. Lots of arithmetic. Be very careful with those signs. Don't lose a negative as I did earlier, but I did find it, so that's good. Thank you very much, and we'll see you on page 3. Won't see you, we'll hear you. Thank you.